In yesterday's lesson, we looked at summing arithmetic sequences, where you would take the first term plus the last term, and then you would multiply it by how many terms there are and divide it by 2. So that was, there were some problems up here like that, where we added the first 25 numbers in those sequences. So today, what we're going to do is we're going to look at what's called geometric series. So arithmetic means you're going up by the same common difference, or you're adding to get to the next term. Geometric means you're multiplying to get to the next term. So here's our formula. The formula is, in order to come up with it, it's a little bit more advanced than we want to get into. So rather than kind of coming up with why the formula works, for this one, we're just going to give you the formula. So here is our geometric series formula. So what this means is if you have a geometric sequence and you want to add all those numbers up together, this is the formula we use. It's the first term times, and then the fraction of 1 minus the ratio to the nth power over 1 minus the ratio. So let's look at the first example and figure out what are the 3 things we need. So the 3 things we need are the first term. We call that T1. We also need the common rate or ratio, and then we also need to know how many terms are there. So first term, not too bad. It's given to us. That's 1. And then the rate is what's happening as we're going from 1 to 2, 2 to 4, 4 to 8, 8 to 16. And for some people, it's kind of obvious. That's multiplying by 2. If you're not sure, or if it's a more complicated one than this, all you do is you just take 2 consecutive numbers and you divide them. So 16 divided by 8, that's 2. And try another 2 consecutive numbers. Is that going to be 2? So 128 divided by 64, and indeed that is also 2. So when you divide 2 consecutive numbers, if it's always the same number, which it is here, then that's a geometric series. And then n is how many terms are there. So with this one, it's small enough where we can just kind of count them. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 terms in this. So then we would say n is 12. And then all we do is we just punch it in our calculator. So let's set up the formula first. This would be S12 because there are 12 terms. We go our first term, which is 1, and then we multiply by this fraction. It is 1 minus the rate, which is 2, to the nth power, in this case 12, over 1 minus 2. Now, whenever you have a fraction like this, there's implied parentheses on top and bottom. So make sure when you punch this in your calculator, you include the parentheses for the top and bottom. The calculator is excellent at order of operations, so if you don't have the top of the fraction in parentheses, it's going to get things wrong. So let's punch that in. And here's our calculator. We have 1 times, and then in top, 1 minus 2 to the 12th. And then I can close the top. Divided by, so this is the bottom of the fraction, 1 minus 2. And so I've got my fraction. Now I can close that fraction, and that should give us our answer. And it's 4,095. So if we add up all of these numbers, 1 to 2,048 as we multiply by 2, the total sum of this is 4,095. All right. So got a couple more examples we're going to run through. Obviously, if you get it, you can probably be done. But if you want to make sure you understand, what do we do if there's a sigma, stuff like that. So example 2 here, it's written out in sigma notation. So still same 3 things that we need. We need first term. We need what's our multiplier, and we need to know how many terms are there. All right, so our first term means you are going to take what's on the bottom of the sigma and plug that in. So that would be -4 times 1.5 to the 1 minus 1 power. So all I did was I replaced this n with a 1, because that's where we're starting. So if we were starting here at 3, you put a 3 in to get the first term. Okay, 1 minus 1 is 0, 1.5 to the 0 power is 1, and 1 times negative 4 is negative 4. And if you're comfortable with geometric sequences and sigma notation, you would know that that is the first term, because this is the first term, and we're starting at 1. That's important. If we're not starting at 1, then you can't just say the first term is negative 4. Okay, r, what's our common rate? That is 1.5. That's from the formula there. If you keep plugging in 2, then 3, then 4 into this equation, you'll see that it keeps multiplying by 1.5. And then n, how many terms are there? Well, if we're starting at 1 and we're ending at 15, from 1 to 15, that is 15 numbers. And, you know, some people might say, well, isn't that 14? Because 15 minus 1 is 14. But you also have to include 1. So if you're counting 1, 2, 3, 4, 5 up to 15, that's 15 numbers. All right, so the sum of the first 15 terms would be the first term, negative 4, times 1 minus our rate, which is 1.5, to the 15 power in this case, over 1 minus 1.5. Don't forget, top and bottom should be in parentheses. And let's punch that in. So negative 4 times, in the top, 1 minus 1.5 to the 15. Close the top, over 1 minus 1.5. Close the bottom, close the entire fraction, and let's see what we get. We get negative 3,495.151123. So I'm guessing this goes on for a little ways. It would stop eventually, but it's a longer decimal. And when you multiply by a rate that's a decimal, that's typically going to happen. All right, so negative 3495.15. And I put approximately because, you know, we are rounding that. Okay, last one, and then hopefully you kind of got the idea. It says, what's the sum of this series? Well, let's figure out the 3 things that we need to know for this. So for term 1, that's 10. Not too bad. That's just the first term. Our rate and our number of terms. So our rate is what's happening from 10 to 30, from 30 to 90, and so on. So that rate is multiplying by 3. That means r is 3. And then n, this is a tougher one. There's the hard way to do it and the easy way to do it. We're going to do it the easy way. So we're going to do 10 times 3, and that gives us 30. And we're going to times 3, and that gives us 90. So we're on term 3 so far, right? 10 is the first one, 30 is the second one, 90 is the third one. 4, 5, 6, 7, 8, 9, 10, 11. So that's the last one in our sequence is 590490. So this is the 11th term. That means that n is going to be 11 in this case. So I just did that by saying, well, I know the first term. I know we're multiplying by 3. So if I just keep multiplying by 3, how long does it take me to get to that last term? That's definitely the easiest way to do it. Probably the best way to do it. The other way to do it is, I'm probably not going to finish it, but I'll at least show you. To finding the nth term, we take t1 times r to the n minus 1. And so if we're trying to figure out that nth term, or we know the nth term, it's 590490 equals the first term times the rate to the n minus 1. Whenever we have an n or an x in the exponent, we have to use logarithms to solve it. And not that logs are bad. I mean, we should not shy away from them. They're doable, but it just creates a little bit more work. Whereas if you just use your calculator and kind of brute force it, you can figure it out. Okay, So the sum of these 11 terms, you start with the first term, you multiply it by 1 minus the rate to the 11th over 1 minus the rate. Punch that in. First term is 10. 1 minus 3 to the 11th divided by 1 minus 3. And we get 885730. All right, so that should hopefully get you enough to get through geometric series.